Hi everyone, in this video I am going to discuss the limit of a function. So first of all, let's understand the geometric meaning of the limit of function at a point x equal to c. So let us suppose that we have a Cartesian coordinate system and I want to draw in a graph of the function y equal to fx. Okay, and c is any point on the x-axis, which is c is any point. So now we want compute the limit x tends to c, then our function is approaches L. So suppose we have a function fx and we want to compute the limits of this function as x approaches c. So this means when our x values get closer and closer to c, the function values fx get closer and closer to some number L. So we call this number L is the limit of function at x equal to c fx equal to L. Okay, so means when our x is x values from values gets x values get closer and closer to the c, then our function will take values get closer and closer to some number L. Okay, so let's discuss the idea of a one-sided limit. So one-sided limit, if we have a Cartesian coordinate system, and we will see that this is the Cartesian coordinate system. Okay, so we have in this function at x equal to c. So one sided limit LHL, left hand limit. So if x approaches c from the left side, when our x is approaches from the left side, c from the left side, so we call it the left hand limit. This take the values L. If our function will take values, that is the c, if x approaches c from the right side, then our function will take values L. This is called left right hand limit, RHL in the short form. Now next definition is that limit x tends to c f of x L if and only if limit x tends to c minus f of x L equal to L and right hand side limit L. Means basically is that our LHL and RHL both are equal at a point x equal to c. So then we can say that limit x tends to c fx equal to L. Okay, we have given limit x tends to c fx equal to L. Then we can also say that LHL and RHL both are equal when our x is approaches to c. Okay, and next is a nice theorem, squeeze theorem. So for the squeeze theorem, if fx less than equal to gx less than equal to hx when x is near c, and given this limit x tends to c fx equal to limit x tends to c hx equal to L, then at a point x equal to, when x is approaches to c, then limit of gx is equal to L. So we will see by the help of this example. So we will see the solution of this example. So we have to show that limit x tends to 0 x square sine 1 by x equal to 0. So by the help of the squeeze theorem. So first of all, we know that the range of the sin x is always between minus 1 to 1. Okay, now we can also say that the range of the sine 1 by x is also between the -1 to 1. Now we will by x square, so it becomes minus x square sine 1 by x less than x square. Now we will compare this is becomes fx, this is become gx, and this becomes hx. Now sequence theorem is saying that we have given the limit x tends to 0 fx and gx, so then we can find the limit when x approaches to 0 of gx. So we have given limit x tends to 0 minus x square equal to limit x tends to 0 x square equal to 0. So by this sequence theorem, limit x tends to 0 x square sine 1 by x equal to 0, because we can say that limit x tends to c gx equal to l, so our c is 0 or our l is becomes 0. Okay, we can do more examples by the help of the sequence theorem. Next is epsilon delta definition, which is we can in another represent of the limit of the function when our x is approaches to c, then fx is approaches to l. So representation is like that. Let f be any function which is defined on any interval that contains the number c. So we will see by the help of the geometrically. So let us suppose that we have a Cartesian coordinate system. This is Cartesian coordinate system, and in this Cartesian coordinate system we have a function y equal to fx. Okay, and c is lies on the x-axis. So this is the c. So c is lies in the interval, so we can say that c plus delta and c minus delta. So our fx is approaches to l, so limit is lies between l plus epsilon and l minus epsilon. This is l plus epsilon, and this is the limit l, epsilon distance. Okay, so when our epsilon, now we want to find the value of the delta, and we have given the value of epsilon. So epsilon we have, which is in a positive number, so we have given epsilon, then we want to compute the value of delta. So if epsilon will become epsilon will decrease, so definitely delta is also decrease. Here we can say that this is the epsilon. Now epsilon is decreased, so our delta is also decreases. Okay, so we will apply this definition on an example. Then we can say that limit x tends to 3 4x minus 5 equal to 7. This is our function fx, and limit of l is 7 and c is 3. Okay, so preliminary analysis of the problem, guessing a value for delta. So we have to guess the value of delta. So let epsilon positive be a given number. We want to find a number delta such that we applies this definition. If 0 less than x minus c less than delta, so 0 x minus 3 less than delta, so this is our c, okay. So 0 less than modulus x minus c less than delta, this implies fx. This is our fx and this is our l, minus less than epsilon. So we can write this 4x minus f 7 less than epsilon. Now we calculate this, calculate, so it will become 4x minus 12 less than epsilon. Now we will take 4 is common as a factor, x minus c less than epsilon. So there we want delta such that 0x minus c less than delta, then 4x minus less than epsilon. Now we will compare these. So our the value of delta will become epsilon by 4. So by the definition of a limit x tends to 3, 4x minus 5 equal to 7. Okay, so we can try more example on the basis of the epsilon delta definition. So it's this is exercise for you. So okay, thanks. In the next video I'm going to discuss the continuity of a function. Okay, thanks.